Good morning. Today we are doing evaluating powers and exponents. So right in the middle here we have our example of what is a power. It's two numbers. The big number we call the base, and then the small number we call the exponent. The big number tells us how many, or what number we're looking at. The small number tells us how many of that big number do I need to multiply. So we have 5 to the power of 3. Or if you want to read it as 5 to the third power, either way, there are 3 5s. 3 of the big number. So they wrote out 5 times 5 times 5. We can evaluate that. We know 5 times 5 is 25. And then we have to do 25 times 5. If you want to multiply that out, 5 times 5 is 25. 5 times 2 is 10. Plus 2 more is 12. So 5 to the power of 3 is also 125. So we're going to be dealing with exponents or powers today. We need to evaluate or simplify these numbers. So first, we have 2 to the power of 3. That tells us we have 3 2's. So 2 times 2 times 2. We know 2 times 2 is 4. So we're done with those two numbers. And then multiply by 2 again. 4 times 2 is 8. In the middle, we have 7 to the power of 2. So we have this big number 7 2 times. So we have 7 times 7. Well, 7 times 7 is 49. Then third, we have negative 3 2 times. This is different than negative 3 2 times. So notice this one, the negative 3 is in parentheses. That means you're writing everything that's inside the parentheses 2 times. So this one would be negative 3 times negative 3, whereas this one over here is the opposite, or negative, and then you're just doing the 3 2 times. See the difference? This negative is on the inside. You have it twice because now a negative times a negative makes a positive. 3 times 3, which is 9. Over here, we still have 3 times 3, which is 9, but one's positive and one's negative, so your answer is a negative 9. We were looking for this answer on the left because we have them in parentheses. Down below, we have 1 multiplied 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we can multiply it. 1 times 1 is 1. Times 1 again is still 1. Times 1 times 1 times 1 is still going to be 1. You really don't need to write that one out if you can multiply 1 times 1 times 1 in your head. Next, we have 2 to the power, or 2/3 to the power of 3. So whatever's in parentheses, we're going to write 3 times. So I'm going to write 2 over 3, 2 over 3, and 2 over 3. Now we're multiplying on the numerator first, the number that's on the top, and because these are touching, we know that's multiplication. 2 times 2 is 4, so we really have 4 times 2, which is 8 in the numerator. On the bottom, in the denominator, we have 3 times 3 times 3. Well, 3 times 3 is 9, so we really have 9 times 3, which is 27. So this right here is our answer, 8 over 27. All right, last one. We have, again, a negative inside the parentheses, so that means we write it every time. Everything that's in here, we're writing 3 times. Negative 4 times negative 4 times negative 4. Well, a negative times a negative makes a positive. 4 times 4 is 16. And then again, multiplied by a negative 4, we know it's going to be a negative. 16 times 4, if you don't know what that is, we can multiply it out. 6 times 4 is 24. 4 times 1 is 4, but plus 2 more is 6. So we have a negative 64. If I am going too fast, please make sure you pause the video. Next, it says write the product as a power, so we need to write it as a base, a big number, with a tiny little exponent up above. So again, the big number is what number are you multiplying? We're multiplying the number 2. And the small number, how many times are we multiplying it? Well, 1, 2, 3, 4. So 2 multiplied 4 times. Same thing here, we're multiplying the number 6. How many times are we multiplying it? 1, 2, 3, 4, 5. So 6 to the power of 5. Last one, we can do the same thing but with letters instead of numbers, or using a variable is what we call this. We are multiplying g, whatever g is, 1, 2, 3 times, so g to the power of 3. Next, we are writing the number as a power. We don't have the same number multiplied out many times, so we need to think, what number could we multiply to get to 49? That's the same number. So I know that 7 times 7 is 49, which we can really write as 7 2 times, 7 to the power of 2. Same thing with 25. What number multiplied by itself gives you 25? Well, 5 times 5 is 25, also known as 5 2 times, 5 to the power of 2. Then 100. Think about this one. What times itself gives you 100? Well, 10 times 10 is 100. So that we can rewrite as 10 to the power of 2. Alright, this one, our words got a little bit on top of each other here, so I'll fix that. It says Carly has 5 times as many silly bands as Brian. So we don't know what Brian has. Let's keep reading. It says Brian has 5 times as many silly bands as Aisha. Well, let's figure out how many does Aisha have. Aisha has 5 silly bands. Okay, that we definitely know. Write the number of silly bands Carly has in both standard form and exponential form. So standard form is just our number, like 75. And exponential is our base with an exponent. So let's start with what we know. We know Aisha has 5. 5 silly bands. Then, if I go work backwards here, Brian has 5 times as many as Aisha. So let's take a look at Brian. He has 5 multiplied by Aisha, and Aisha also has 5. Okay, then moving along, Carly has 5 times as many silly bands as Brian. Carly has 5 times, means multiply, whatever Brian has. Well, Brian has 5 times Aisha, which is 5. So 5 times 5. So it says, write the number of silly bands Carly has in both exponential and standard form. So Carly has 5 times 5 times 5. Well, that's the number 5 multiplied 3 times. So exponential form is 5 to the power of 3. Notice we're only focusing on Carly. We don't really want to know about Aisha and Brian anymore. And then standard form is just a number. We got to multiply them out. 5 times 5 is 25. So we have 25 times 5, which we actually multiplied earlier, 125. That is standard form. So those are our 2 answers. Flip over to the next page. Evaluating powers with variables. Variable, again, is a letter. So they're telling us evaluate when x is a negative 9. So anytime I see an x, I'm going to plug in negative 9. So x, that whole thing, is to the power of 2. So that's why I'm putting it in parentheses. X isn't just 9 squared, it's negative 9 squared. So we have negative 9 multiplied 2 times. Negative 9 times negative 9. We know two negatives multiply to make a positive. And use your multiplication table. 9 times 9 is 81. Then we have b, which is 7, b to the power of 3. So we have 7 to the power of 3. Oops. 7 to the power of 3 is 7 times 7 times 7, 7 3 times. So we can multiply 7 times 7 is 49. but then times 7 again. 7 times 9 is 63. 4 times 7 is 28. So 28 plus 6 more gives us 34. So our answer when we multiply those is 343. Last one, evaluate p to the power of 3 when p is 10. So we have 10 to the power of 3. So that's 10 3 times. 10 times 10 times 10. 10 times 10 is 100. So we have 100 multiplied by 10. When you multiply by 10, you're just figuring out how many zeros are there. It's 10 times what we just had, which would be 1,000. Last page. This is our pencils ready. I would like you to try these 4 on your own. And then when you're ready, click play to see if you got them right. So it says write the product as a power. So we have 8 times 8 times 8. So our big number, our base is 8. And we're multiplying it, our exponent, 1, 2, 3 times. So 8 to the power of 3. Second, we have 5 being multiplied. And how many times are we multiplying it? 1, 2, 3, 4, 5, 6. So 5 to the power of 6. These ones are evaluate. Remember, evaluate means simplify or solve. So we have 2. We're multiplying it 6 times. 1, 2, 3, 4, 5, 6. So we know 2 times 2 is 4. So we're done with these. Then 4 times 2 is 8. And then we have 1, 2, 3 2's left over. 8 times 2 is 16. So we're done with those. Times 2 times 2. 16 times 2 is 32. Times 2. If you don't know that one, we can write it out. 32 times 2. 2 times 2 is 4. 3 times 2 is 6. So we get 64. That's a lot of multiplying. You got to be careful what you've already multiplied on that. And then the last one, we're multiplying 6 2 times. 6 times 6 is 36. Alright, if you have questions, please let me know. Otherwise, your homework is on, right here, powers and exponents. Mission